Welcome back to the Scotti-BYTE channel, and this is Scott. And today we're going to talk a little bit about networks and containers. So if you've been following the channel for a while, you note that I talk a lot about networks and VLANs. So LXD and Docker default to a NAT network that's usually addressed in a private network range of 10.0, and I found them to be in the .3 and .5 and .7 networks. So when a container is created, it uses a NAT mode by default, which means that you have to externally advertise the application ports on the network that will access those containers. An alternative to this is using a bridge mode, which can present the container directly on the target LAN with a unique address by acting as a network switch through a physical adapter on the container host machine. So host mode, as it's sometimes called, simply shares the address of the container host for the application, but must be careful not to conflict with ports that are in use by other applications on the container host. And then we have something called MacVLAN. And MacVLAN is kind of a multi-purpose interface, but it allows connection of multiple interfaces on a parent NIC and can also use a virtual LAN or VLAN tag to present multiple MAC interfaces for layer 2 routing. And ipvlan is similar to MacVLAN, except that the endpoints have the same MAC address. There's many other network types that containers can use, things like bonded, teamed, VXLAN, ipvlan, VETH, and others. And for the purposes of this video, we're going to leave most of those out of scope because I think it would just make it too complex. So, what about standard container NAT? Well, those of you that know that I use a QNAP, I found this QNAP screen in creating a Docker container to be very handy to explain exactly what's going on with a container NAT network. So this is an example of an application. It really doesn't matter what it is, but by default, the applications are usually brought up in NAT mode. So with the Docker command, if you don't do anything special with a Docker run, you're going to be using NAT mode. And you know you will be because if you read the Docker Hub documentation, you'll see that they present inside the container uses various port numbers. And you can see in this case, there's a list of 4 port numbers that they're using in the container. And then you have the option to translate or expose those host ports at a different port number from what is being used inside the container. But you can never change the container port number because otherwise the application won't work. Okay. So containers using NAT. So if you're at a LXC command line to create a LXD container, and we did a LXC launch Ubuntu 2004, and I just call this container AAA-NAT. I use my default profile, and then I use my switches that I typically do, which is to say that it's a privileged, security privilege is true. Default memory cap is 2048 megabytes. And CPU allowance is at 20% and set it up to auto start. When I do a LXC list, I get a container that looks like this, and it's running at 10.0.7.7. So that is a NAT container. So then we have containers using bridge mode. Well, on the container host, you can create a bridge for your container. And the way we do that is we're going to CD, this is on the actual container host, the host that's going to run LXC or the host that, say, would run Docker. And you would CD into etc-netplan/netplan. And then you're going to go edit the YAML file that's out there. There may not be one, or it may have a different name. Example names that I run across pretty frequently are things like 01-netconfig.yaml or 50.cloud.init.yaml. The numbers just indicate in which order it should be considering those YAML files. But you can edit one of those YAML files, maybe make a backup first of anything you have out there. So then, YAML files in indentation counts, as Brian from Awesome Open Source will tell you. And here's what your YAML file should look like. So this thing kind of assumes that ETH0 is your physical device that you're talking about, and it creates a bridge on ETH0 called BR0. Probably your device will be called something other than ETH0. So then after you edit and create that file, you're going to do a sudo netplan apply, and that processes those commands and should be adding the bridge. And when you do a if config, you should be able to see a new device called BR0, which is that bridge. So then if you do a LXC config device add Ubuntu 1 is the name of the container I want to create, and I say ETH0 nick, where nick type is equal to bridged, and the parent is going to be now the bridge that I just created, and the name is ETH0. That's the name inside the container. Now, more interesting than bridged is Macvlan, and I've covered Macvlan in some of my other videos, but I wanted to revisit this and draw a picture because I thought this picture would be very meaningful. So here's your container host. It's this computer up here in this gray, and we have this thick gray line, and everything inside this thick gray line is that container host. So what I've done is I've decided to present 4 containers. So here's a container, here's another one, here's another one, here's another one. And if you look at the MAC addresses with MacVLAN, each container gets its own MAC address and a separate MAC address, which is really nice. And then, likewise, the DHCP server out on the network can assign them each a unique IP address. In this case, I just said it was something like 100.10, 100.15, 100.20, and 100.25. And then the host will just say arbitrarily it's got a different MAC address, and it's running at 192.168.100.100. And I just arbitrarily said that its Ethernet device is called ETH0. Yours is going to differ depending on your hardware. Okay, so that's what a MacVLAN looks like. So how do you use MacVLAN with LXD? Well, we do a LXC profile create VLAN 100 because that address range on 100 is actually going to be a VLAN. So in order to use the VLAN, it's a prerequisite that you've gone out on your router, your managed router, and you tell your managed router that you want to create a VLAN, and you're going to create VLAN 100. The name here doesn't count so much, but the tag VLAN number of 100 does count. So we create the profile. Then what I say is LXC profile device add VLAN 100 ETH0 nick type equals MacVLAN, parent equals, well, whatever the name of your Ethernet device is on your host, because again, I told you that could differ. And then VLAN equals 100. That's the part that really counts here. And then to create a container, we're going to create an Ubuntu server here. So I say LXC launch Ubuntu :2004 because that's the version of Ubuntu I want. I'm calling it my host. I'm using the default profile, -- profile default. And I'm also using the profile VLAN 100. So -- profile VLAN 100. And then again, my security privilege true, my limit I set to 2048, and I set my CPU allowance to 20%. Again, the memory and the CPU allowance are caps. That's all they are. And then I say auto start is true. So that's all there is to that. So now using MacVLAN with Docker. So we do a Docker create or Docker network create -d So detach this operation and make it MacVLAN, make it a MacVLAN. That's what we're creating. And we're saying the subnet's going to be 192.168.100.0 with a 24-bit submask. The gateway is going to be 192.168.100.1. And the parent is going to be, well, whatever the parent is. And in this case, I say ETH0. Yours may differ. And I say the name of this network is going to be VLAN 100. So now that I have a network, I'm going to do a simple Docker container. In this case, I'm going to create a Docker container to run an Alpine server. So I say, and Alpine's a real lean Linux container that a lot of people use for some simple apps. So I say Docker run -rm -dit -network VLAN 100 -name Alpine-server. So that is 2 dashes, even though it didn't show up in the slide that way. And then Alpine:/latest. The backslashes are simply because I wanted to present these on different lines. But if you type them all, you can put it all on one line. And Alpine:/latest, and then finally ash. So ash is the shell that Alpine uses to gain access to the command line in the container. And then if you want to see what that did, you can say Docker container inspect Alpine-server, and it will list out everything that it's built as a result of those commands. So now we have a MacVLAN network with Docker. There's something else called ipvlan, and out on the net you find it a lot. And I wanted to show you and tell you what it was because I don't think in very many cases it's going to be attractive to use, but kind of watch it because here's the differences between ipvlan and MacVLAN. So another picture again, and this looks just like our last picture. The difference is we have different IP addresses, but you'll notice that in every case, the MAC address of the container is absolutely identical for all 4 of the containers and also for the host. Basically, the host MAC address becomes the MAC address of the containers. And that's by definition what ipvlan does. So MacVLAN allows you to have unique MAC addresses across every container. This one has to share the MAC address. And I put a big blue thing here to tell you about this. I said, shared MAC addresses can affect DHCP services. Well, that shouldn't be any big surprise because DHCP servers allocate IP addresses based on a unique MAC. So you're going to have to manually define these addresses, and you're not going to be able to use DHCP. However, this is useful because some switches can restrict the maximum number of unique MAC addresses per physical switch port. And if your container server is connected to one switch port and it's serving a lot of containers, you might actually be forced in some cases to use ipvlan for that reason. Okay, so in summary, containers created on the container NAT network can add security by only exposing selected application ports. And that's kind of the default, and that's what most people do right now. NAT address containers can be harder to interface with because of internal to external port mapping. We showed that up front in the first slide. And bridged and MacVLAN networks make Docker and LXD containers more functional as hosts on your LAN or VLAN. And then Docker and LXD allow the creation of virtual network components like virtual switches, subnets, and even routing rules. So those are things to remember, and that expands the functionality of your containers. Anyway, thanks for listening today, and please subscribe and like to the channel if you want to see more content like this, and we'll see you next time.